Good morning, dear students. In the previous 9 parts of determinants, 9 videos are passed away. Successfully, we did those videos, and I think that I hope that you followed it well. Exercise 4.1 and 4.2. Now we are going to 4.3. So many concepts we study, we discuss, and many properties like that. Now, here, before going to start the 4.3 exercise, a small topic, a small concept, not topic, a small concept that is related to geometry. In a two-dimensional geometry, we studied in the straight lines the area of triangle. Okay, now? By using that one, we have to solve these problems. But it is in geometry. But that concept will be changed into determinant. Okay, now you see there. I want to explain. You see, suppose in the plane, suppose there are 3 points whose coordinates are x1, y1 and x2, y2. It is x3, y3. Okay, now? Then, what is the area of triangle whose vertices are given? A, x1, y1, B, x2, y2, C, x3, y2. Of course, the property theorem proof is there, but it is not needed. In order to explain it, we studied it well. I myself, I taught in the last year about this area. It is okay. This area, that is delta ABC, that is area of triangle ABC, is 1 by 2 with modulus x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. It is square units. Okay, now? You see, there we studied it well and we applied it in the solving of problems. Yeah. You see, in the bracket, y2 minus y3, y3 minus y1, y1 minus y2. In order, some order is there. In the brackets, the difference of y coordinates are there. Whereas for the multiple of bracket, x1, x2, x3, that is x coordinates of the 3 vertices of triangle, for which we are finding the area. x1 multiple in the bracket y2 minus y3, x2 y3 minus y1, x3 y1 minus y2. Like this is there. Of course, it is a fantastic concept. Yes, okay. But what is the relation? It is purely geometry, x coordinate, y coordinates, area of triangle. But we convert this concept into determinant. You see, just it is 1 by 2 modulus. It is x1 of y2 minus y3. We take minus x2 of y1 minus y3. Will you agree? If you interchange it, y3 minus 1, y1 minus y2 minus y2. And x3 of, as it is, y1 minus y2. Okay, now? It is 1 by 2. We may write it as in determinant x1, x2, 1, y1, y2, in x1, y1, 1. It is x2, y2, 1. It is x3, y3, 1. Okay, Nana? You see, this expression, the area of triangle in geometry, that expression can be converted just a small multiplication is there. It's simply we get a minus here in order to interchange the y3 and y1, y1 minus y3. This expression is nothing but a determinant of this 3 by 3 matrix. You see x1, y1, 1, x2, y2, 1, x3, y3, 1. x1 of that row and column is denoted y2 into 1, y2 minus y3. Yeah, y2 minus y3. Minus x2. The determinant is calculated along first column. I am taking first column or first row. Whatever it may be, it is same. We know it well. So x1 of this one minus x2 of this row and column denoted y1 into 1, y1 minus y2. Yeah, correct. Plus x3 of it is plus, minus, and it is a plus. We know it well. x3 of this row and column denoted y1 into 1 minus y2, y1 minus y2. So the area of triangle can be converted into determinant. That determinant you see, it is just the first point A, x1, y1, 1 is common. Second point B, x2, y2, 1, x3, y3, 1. Okay, now? So the area of triangle whose vertices are given, not this formula. The formula is this one. Of course, it is in the modulus. While we are calculating the area, then it is a modulus because area is always positive. It is geometry formula and this is this determinant algebraic formula. Okay, now we are converting this one. This concept is used here only. Okay, now in this one. Just wait. Yeah. By using that property, now we are going to solve the problems. In the exercise 4.3, only 5 problems are there. At a stretch, we have to solve that one. You see that observation. Number 1. The first problem is to find the area of triangle whose vertices A 1, 0 and B 6, 0, C 4, 3 is there. I will solve 1 and 3. Second is given a homework. You see delta is equal to 1 by 2 with the modulus x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, that's quite nice. Like that, here delta is equal to 1 by 2 with the modulus, determinant 1, 0, 1. This is x1, y1, x2, y2, x3, y2. 6, 0, 1, 4, 3, 1. It is 1 by 2 into is there. It is 1 of, in the first row I am calculating the determinant. 1 of this row and column is deleted. 0 into 1 is 0, minus 3. Minus 0 into anything. 0 into anything is 6 into 1 is 6 minus 4 plus 1 of this one. It is 18 minus 0. Okay, na? Yeah. It is 1 by 2 of, this is minus 3, it is minus 2, 0 is 0, plus 18. Okay, now? It is 18 by, not 18, it is 15 by 2. I think, you see one more time, is 1, 0 and 6, 0, 4, 0. 1 of 0 minus 3, minus 0 into something is 0, plus It is 1 of 18 minus 0. It is 18. Yeah. So this is 15 by 2 square units. Okay now? Yeah. Next, we'll go to third one. Given vertices. What are the vertices? Given vertices are capital A is minus 2 comma minus 3. B 3 comma 2. C minus 1 comma minus 8. Now delta is equal to 1 by 2 with modulus determinant x1 y1 x2 y2 x3 y2. This is minus 2 minus 3 1. This is 3 2 1 minus 1 minus 8 1. Okay now? Now see that. It is 1 by 2, same as it is. It is minus 2 of row and column is deleted. 2 into 1 is 2 minus of minus 8. Minus 3. Okay now? Minus 3 into this one is deleted. So we get these elements 3 minus of minus 1 plus 1 of. Okay now it is minus 24 minus of minus 2. Put it in a modulus. It is in modulus because area is positive. This is minus 2 into this is 10. Minus 3 into this is 4. It is minus 24 plus 2. It is minus 22. Will you agree? The minus into minus plus 3. 3 plus 1 is 4. Minus 1 plus 8, 10, no minus 2. So it is minus 1 by 2 of minus 20 plus 12 minus 22. Okay now? How much? Minus 42. You see that? It is minus 42 plus 2 minus 32. 32 by 2 is 16 square units. Okay now? Right. Even though we get minus, but it is a positive value. Why? Because area. Okay now? Like that we have to solve. I will. Next, second one. Second one is an important type concept, so that the points we are given capital A, capital B, capital C are collinear. Collinear means, you see it, I will give. Suppose this is A and it is B, it is C, they are lying on the same line. Then they are said to be called as a collinear. Then what about the area of triangle ABC here? It is 0. The triangle will not be formed by those vertices, those points as vertices of a triangle. Not be formed. So here the concept is the area of triangle, if it is 0 means it is collinear. That concept we have to use here. So here given, we are given A, capital A is A comma B plus C. Capital B is equal to B comma C plus A. Capital C is equal to C comma A plus B. So this is just like x1, y1, x2, y2, it is x3, y3. That is the concept. Now, we verify delta ABC, that is a determinant half into determinant x1, y1, 1. A, B plus C, 1. B, C plus A, 1. C, A plus B, 1. Okay, na? Okay, Nana? Observe. We are given only the points and we are asked to show those points are collinear. With what concept I am trying to solve this one? Means if the area of triangle ABC, if it is 0, this determinant is 0, then it is said to be called as a collinear points. Now you see, it is 1 by 2 determinant. You see, in the properties of determinant, in the column 2, each element, all the elements of column 2 are the sum of 2 numbers. Sum of 2 terms, B plus C, C plus A plus B. A property is there in the determinants. So, that determinant in which column 2 is sum of 2 terms. Then its determinant value is sum of 2 determinants. That means A, B, 1, B, C, 1, C, A, 1, plus again it is A, C, 1, B, A, 1, C, B, 1. Okay, na? Like that, we may follow it like that. This is one method. If you solve by direct method, we may get 0. It is one method. And one more method I want to teach. You see, by using, without expansion, by using here the properties, you see now. Here, simply C1 is added with C2, C3. C1 is added with C2 plus C3. This is C1 and this is C2. Okay, na? Or simply C2. We may write it simply C2. Then what will be happen? We will see. It is A plus B plus C. And it is B plus C and 1. Here also A plus B plus C, it is C plus A 1. And here also A plus B plus C, A plus B 1. Okay then? Very simply I am ready. C1 is added with the C2. Even though if you add C3 also, but not needed, C1 is added with the C2. Then these are the terms. You see, A plus B plus C is taken as a common because it is a common in the column 1. So we get like this. Okay, na? Okay, na? Here 1, 1, 1 because A plus B plus C is common taken and put it in front of determinant. Then column 1 is 1, 1, 1 and column 3 is also same. The 1 and 2, two columns are identical. Two columns are identical. So it is its determinant is 0. So totally it is 0. So this determinant is 0. That means the area of triangle is 0. Here the concept is we are using the determinant properties of determinant. Okay, now like this you solve it. If you go like this, we get a 0. Okay, now? So delta, that means triangle ABC, the area of triangle ABC is 0. That implies the vertices A comma B comma C are collinear. Okay, now that is what we need. It is an important concept. Once again, you see the what are the vertices? We are given in the problem 3 points and we show that they are collinear. Collinear means lying on a line. Then with those points, the triangle will not be formed. So its area is 0. By using that concept, we solve it. Okay, now like this. Pass. Okay. Now third problem. Third problem is find the value of k. Value of k if the area of triangle is 4 units, whose vertices are this one. So number 1, delta ABC, we will write it as a delta ABC is equal to 4 square units. We are given 4 square units. Okay, na? But 4 square units is given. Yeah. But the vertices are this one. What are the vertices? You see, capital A is equal to k comma 0, B is equal to 4 comma 0, and C is equal to 0 comma 2. So it is 1 by 2 determinant k 0 1 4 0 1 0 2 1 is equal to 4. It is 1 by 2 into k of row and column selected. It is 0 minus 2 minus 0 into anything is 0 plus 1 of 8 minus 0 is equal to 4. Okay, now every time I am giving explanation for this how to expand the determinant. Okay, now many number of times. K of 0 minus 2 minus 0 to anything is 0 plus 1 of 8 minus 0. Now this is 1 by 2. With the modulus we put it. This is minus 2k minus 0 plus 8 is equal to 4. It is minus 2k plus 8 with the modulus is equal to 8. This 2 goes to that side is 8. And it is minus 2k plus 8 is equal to plus or minus 8. I am releasing the modulus. The modulus. Without modulus means it is plus or minus. Putting here or otherwise there. Both are same. Minus 2k is plus or minus 8 minus 8. Okay, na? You see, minus 2k is if you take minus 8 plus 8 or minus 2k is minus 8 minus 8. Here k is equal to 0. Okay, na? Here k is equal to minus 16 by minus 2 is equal to 8. Okay, let's see that. Is it okay? That 2 goes to that side. 2 into 4 is 8. This is minus 2k and 0 and anything is 0. There only 8 is there. The 1 of 8 minus 8 is there. So it is minus 2k plus 8. This 2 goes, that side is 8. And I am releasing this modulus. So it is plus or minus 8. Okay, na? So minus 2 plus 8. That 8 goes to that minus 8. One time plus 8, other time minus 8. So minus 16 by minus 2 is 8. Here 0 by anything is 0. So this is the. And again, I want to solve one more problem. You see, it is the second one. Given the points or vertices, the vertices A is equal to minus 2 comma 0, B is equal to 0 comma 4, C is equal to 0 comma it is k. Now also delta is equal to, it is 4 units. We are given 4 units. 4 units. That implies 1 by 2 determinant minus 2, 0, 1, 0, 4, 1, 0, k, 1. It is 4. It is 1 by 2 with modulus. It is minus 2 of the row and the column. Minus 2 of. It is 4 minus k minus 0. Anything is 0 plus 1 of 0 minus 0 is equal to 4. Okay, Nana? Minus 2 into 4 into 1 is 4, minus k into 1 is k, 0, row column, it is 0 totally, 1 also. 1 of 0 into k is 0, 0 into 4 is 0. So it is minus 8 plus 2k na? Here, minus 8 plus 2k with the modulus is equal to 8. 2 comes to this side, 2 into 4 is 8. It is minus 8 plus 2k is equal to plus or minus 8. Okay, now? So 2k is equal to plus or minus 8 plus 8. So one time it is 8 plus 8, other time it is minus 8 plus 8, 2k value. So k is equal to 16 by 2 is 8. Here k is equal to 0 by 2 is 0. Okay, now? Like that we can. So k value. Here k value is 0 comma 0 may come or 0 comma 8 may come. Okay, now? Like this. Yeah. First. Yeah. Okay. Fourth one. It is of some different problem. Two problems are given. One problem, first problem is homework. And second problem I am solving. Find the equation of line joining the 2 points 3, 1 and 9, 3 by using the determinant concept. It's a well problem. Okay, now? You say given points are A 3, 1, B 9, 3. In geometry it is very simple, using the 2-point form. X minus 3 by 3 minus 9, y minus 1 by 1 minus 3, and solve it as a simplification, and we will get the equation. But here you say by using the determinant concept, okay, na? It is a required line A 3, 1, it is B 9, 3. Okay, na? And we have to find by using a determinant concept. Let P x comma y, you see that, let P x comma y be any point on the required line, passing through 3, 1 and 9, P be any point means the locus of that point P. That point is everywhere is there. Everywhere is there. That means it forms the straight line. So that we can get a straight line. But moreover, here delta PAB is equal to 0 na? Because the triangle will not be formed because those points are lying on the line. So that is 1 by 2 determinant x, y, 1, 3, 1, 1, 9, 3, 1 is equal to 0. Okay, now? And it is, the 2 will come to this side, it is 0, okay? It is x of 1 minus 3, many times I saw. And it is minus y of 3 minus 9 and plus 1 of 9 minus 9 with the modulus is equal to 0. That 2 comes to this side 0. X of 1 minus 3 minus y of 3 minus 9, 1 of 9 minus 9. So it is minus 2x minus 6y plus 0 with the modulus is equal to 0. Okay, na? Yeah. But here you see, you take 2 as common. So 2 of minus x plus 3y is equal to 0. Okay, na? Observe me. I am taking 2 as common. Not minus 2, 2 as common. Now 2 also comes to this side, it is 0. Now plus or minus of minus x plus 3y is equal to 0. That implies minus x plus 3y is equal to 0, or one more, plus or minus there. Two types of equations will be formed. I am using plus into something, is this one. Minus x or minus 3y is equal to 0. Okay, Nana? This is very good concept. These are the equations of the required line. Okay, na? Yeah. Is it clear? Now. The last one I want to explain. You see, the fifth one. It is objective type question. The area of the triangle is 35. Given delta is equal to 35 square units. 35 is there. And the points are, we know it. A is how much? 2 comma minus 6b, 5 comma 4c, k comma 4. And we have to find the k value. It is 1 by 2 with modulus 2 minus 6 1, 5 4 1, k for 1 is equal to 35. So 2 of modulus, we have to put it into modulus, don't forget. Modulus of, it is 4 minus 4. Okay, na? 4 minus 4. Minus of minus 6 into 5 minus k. You don't forget, minus, already minus is there. While we are calculating the determinant, minus plus minus must be there. And here the minus 6 is the element. And plus 1 of round column, it is 20 minus 4k. Modulus closes to 35, 70. Okay, na? Right. Now, releasing this modulus, I want to take up the modulus. You see it is 0 na? And it is 6 plus 6, 30. It is plus 6 into minus 6k. It is 13 and 6 5s. So 30, it is again 6k. It is plus 20 minus 4k is equal to plus or minus 70. Will you agree? Because releasing the modulus, we get plus or minus 70. It is okay na? It is 0. It is 30 minus 6k. 30 plus 20 is 50. Minus 10k is equal to plus or minus 70. Minus 10k is equal to plus or minus 70 minus this 50. Means it is plus 70 minus 50 is 20, or minus 70 minus 50 is minus 120. It is 10k, minus 10k. So k is equal to 25 minus 10 is minus 2, and or otherwise k is equal to minus 20, 120 by minus 10 is 12. Okay, Rana? So 12 comma minus 2 is the correct answer. 12 comma minus 2. You see there? This is minus 10k minus 50 plus 12. 12 comma minus 2. I think this is okay na? So this is the correct option. Okay na? Like this we have to solve. Yeah, pass.